stretch here to show you a little bit of the DCS F-86 Sabre, new from Digital Combat Simulator Eagle Dynamics. The F-86, as you guys probably know, is one of the first jet fighters of the United States Air Force, Korean War era fighter. And in this video tutorial, we'll be doing just a cold start, taxi, takeoff, one loop around the pattern, and a landing. I'll just be giving you a very quick introduction to the F-86. So for starters, for a cold start, let's just make sure that all our switches are good. We want to make sure all the circuit breakers here are in. We want to make sure that the alternate gun heat switch is off. Cockpit air controls are normal, and the air pressurization switch is set to pressure. Alternate trim switch is set to normal, and the longitudinal alternate trim switch is also set to normal. And the flight control switch is normal. Want to make sure the throttle's off, speed brake switch is centered, and the speed brake override switch is aft, and the flap switch is centered. And coming here, we want to make sure the jettison switches are off, and landing gear lever is down. Emergency fuel switch is off, and here we want to make sure the gun sight is caged. Coming down the center, we want to make sure that our alternate gear switch and canopy jettison handles are in. And we want to make sure that the arm switch is on off. That the alternate flight control lever is here is in. And the engine master switch is off, battery switch is off, and all of our air start and generator switches are, or the generator is on, the air start switch is off. And we want to make sure all of our electrical equipment here is off. And radio is off. Okay. So, in order to start the F-86, we're going to need to turn on ground power. So let's call for ground power now.
Chief, turn on the ground power.
Because the radios are off and the canopy's open, we're just sort of saying it directly, just with our voice. Once the ground power comes on, you'll see the fuel tank selector works. You'll hear the ground power inverter turn on, and a couple of other switches start working. Landing gear lever lights work. Okay, so here's what's going to happen. We're going to turn the engine master switch on. This opens the primary fuel tank valve. And then we are going to move the starter switch here momentarily to starter and then up to the battery position. When this happens, the engine start sequence is going to begin. At 3% RPM, we're going to move the throttle outboard to the middle outboard position. This energizes the starter and preps the fuel pumps. When the RPMs reach 6%, we're going to then move the throttle outboard again to the idle position, and this begins the flow of fuel and starts ignition. After this happens, we're looking to make sure that we hit 23% RPM within 1 minute, and we're going to watch our EGT to make sure it doesn't spike above 950 degrees Celsius here, which is the maximum allowable temperature during the start. If anything goes wrong, we'll hit the push to stop starter button here to abort the start. Once the engine's online, we're going to be checking our oil pressure, our fuel flow, and our exhaust gas temperature to make sure they're normal. This all happens pretty quick. That's why I told you about it beforehand. So now that we're ready, let's go ahead and do it. Watching the starter here. Watching the RPMs. It's about 3%. Let's move it outboard to the first position. And 6% outboard again. Start sequence begins. We're watching the EGTs. Fuel flow is coming up. Okay, and the engine is started. EGTs have stabilized below the run red line, which is here. Fuel flow is stabilized at about 1,200 pounds per hour. And RPMs are stable at 30%. Note that since the F-86 is a straight tube, it's not a turbofan engine like most modern jet aircraft, it idles at a much lower RPM. And in fact, it idles at such a low RPM that the generator can't even run at idle power. I'll show you this now. Let's turn off the ground power.
Chief, turn off the ground power.
Copy. Ground power is now off.
With the ground power off, you'll note that the generator warning light is on. We'll have to increase power just a smidge above idle. Take it to around 40% RPM. You see there, the voltmeter comes up and the ammeter, the load meter comes up too. And so I like to idle it around a little bit above 40% just to make sure that we got enough power, power in the generator to power all the systems. Okay, the next step is to begin our flight control checks. The F-86 has 3 hydraulic systems, the normal, alternate, and utility hydraulic systems. Hydraulic pressure is indicated here, and you can switch between the 3 hydraulic systems. Normally, flight controls are powered by the normal hydraulic systems. In an emergency, they're powered by the alternate system, and speed brakes and flaps are powered by the utility system. So, as you can see here, the alternate flight control hydraulic system light is on. If we move the switch temporarily to the reset position and back to normal, the light comes off. We can also take this opportunity to check all of our lights here, make sure that they're all working. It's good. And now, in order to do our flight control checks, what we're going to do is with the normal system indicated here, we're going to just briefly move our flight controls and make sure that all of our elevator and aileron and rudder surfaces are moving normally. I want to make sure that the normal system is bleeding down. You're not going to be able to bleed it down below about 2,000 psi, but you can see it working. Next, we're going to check the alternate system. So let's switch indicator over to the alternate system here, and then move the alternate switch on. The light comes on, and we can see if we move the flight controls, we want to make sure that everything is still working normally. And we want to make sure that this is bleeding down. Once it gets below the yellow line, it should move to the normal system. You can see the light coming off there. That means that there's insufficient pressure in the alternate system, and we move instead to using the normal hydraulic system. Okay, so now what we want to do is reset and go back to norm. And now what we want to do is test the alternate hydraulic valve. And so we want to hold this in the reset position, like so, and pull the alternate hydraulic flight control emergency switch. When we do this, the alternate transfer valve will open, and we want to check operation here. So again, we want to move the flight controls and just verify that everything is working. Now, if we allow flight control, the hydraulic pressure to restore, you'll note that with the alternate transfer valve on, the hydraulic pressure is going to peg well above the red line of 3,200 psi. This is normal. We'll let that happen so you can see it. This is a normal consequence of using the alternate transfer valve. So what we want to do now is restore this to the normal position and push the flight control hydraulic alternate handle back in. And when we do this, after we do this, we want to reset the system back again, go back to the normal position, and just verify that we have normal pressure here, which we do at about almost 3,000 psi. Okay. Let's continue our start setup. So we'll turn on the position lights to steady, and we'll turn on the radio and the IFF to standby. With this done, we're ready to taxi. First thing we need to do is bring the speed brakes in. You can't see the speed brakes from the cockpit. What I like to do is switch this to the utility position, and since the utility hydraulic system powers the speed brakes, you can when we push the speed brakes in, you can watch it drain. When it stops draining, you know the speed brakes are all the way in, and we'll go back to the normal position. We should also lower the flaps for taxi and takeoff, so we'll push them all the way down and verify the flaps are coming down, which they are. And then we can return the handle to the center. Let's check the flight instruments. Airspeed indicators are 0. We check the compass, the magnetic compass against directional gyro. Check the attitude indicator, and the altimeter is indicating field elevation. Turn and bank and vertical speed are all good. Voltmeter is generating about 28.5 volts. Lights are on. We're ready for taxi. We're going to add a bit of power to taxi. Now, nose wheel steering is a push and hold situation in the F-86, so if you want to steer, you have to hold down the nose wheel steering button on the stick. The F-86 is pretty unstable with the nose wheel steering. It's very easy to overcorrect and get into a pilot-induced oscillation situation. Just be sure to release rudder pressure before you, like as early as you roll out on the turn, and you should be fine. And just avoid the PIO. Before taking the runway here, we're going to do a turning check. Just make sure that all the instruments are turning the way we'd expect them to. And we'll also do a brake check here. Brakes are working. Okay. Let's do our before takeoff checks before we take the runway. Pitot heat on. Pitot tube takes about a minute to heat up, so be sure to give about a minute's time lead before you take off into cold weather and clouds. We're also going to toggle the dust screen here by momentarily moving the switch to retract and then back to extend. This is a dust screen in front of the engine intake. Just by toggling it, we shake off any dirt that might be on it. We're going to need to check our trim. Trim is done using the four-way hat on the stick, and when it's in trim, this light here lights up. So let's just pull the stick, hold the trim down button until the light lights up, and now we're in trim. We're probably already in trim and roll, so we're just going to nudge it a bit and just verify, yes, we're in trim. Same with rudder. I'm going to zoom out here, and we're going to use the rudder trim button here. Just verify that we're in trim. Okay. And flaps are down, handles centered. We're going to close the canopy now by moving this switch forward. After the canopy seals, leave the switch in the forward position for 2 to 3 seconds just to ensure a tight seal. Alright, we're ready to take the runway. So we'll hold down the nose wheel steering button again, add a bit of power, and turn onto the runway. Okay, let's straighten out the nose wheel before we come to a stop. Alright. Okay. We're going to do our takeoff. As part of the lineup checks, we're going to check the emergency fuel system. When the emergency fuel system is first engaged, RPMs can spike, so you never engage it at full power. Instead, we're going to bring the throttle up to 88% RPM here, holding the brakes. And once it's up to 88%, we're going to engage the emergency fuel system. RPMs will spike, but they won't redline. Should take about 3 seconds for it to stabilize. If it takes longer than that, you should abort the flight. Now that it's stabilized with the emergency fuel system on, let's bring it up to full power. There should be no overspeed. And now we'll move the emergency fuel system off. The RPM should drop, but then stabilize within 3 seconds. Okay, we'll turn it back on. There should be no drop. And we should note that the RPMs are as indicated for the current temperature. There's a chart in the F-86 checklist, and for this particular temperature it should be 98%, so we're good there. Let's turn the emergency fuel system back off. There's no drop. Now we're going to do our pre-takeoff checks at full power. Should be almost 100% RPM, oil pressure in the green, EGT in the green, and fuel flow as expected. We're ready for takeoff now. At our current weight, takeoff speed is going to be about 110 knots. Rotation speed is going to be about 110 knots. We're going to press the nose wheel steering button and release the brakes. I'm going to come off the nose wheel steering pretty early just because it's so squirrely, and we'll steer with the air rudders. Okay, nose wheel steering's coming off. I'm using larger rudder inputs now for the air rudders, looking for 110 knots. That's 110. Rotate. The plane comes easily off the ground with full flaps. I'll use trim to maintain nose position. Positive rate gear up. Gear lights are out. 150 knots, flaps up. Watch the trim. We'll climb to 1,500 feet, and we're going to maintain our speed at 170 knots. This plane's really got a lot of kick, so we're going to reduce the throttle here to maintain 170 knots. It climbs very well. The flaps up, we can return the switch to the neutral position. Okay, there's 1,000 feet. Let's begin our crosswind. I'm going to fly the pattern at 170 knots here. Okay, there's 1,500 feet. Let's lower the pitch. Keep it in trim. At this point, our after takeoff checklist would involve retracting the landing lights, but since we're just staying in the pattern, we'll leave them extended. Okay, coming off the throttle now. Let's increase our altitude. We're starting to get kind of low. And below 170, gears coming back down. Keep it in trim. And let's go full flaps. We'll adjust speed to adjust power to maintain our speed. Somewhere between 150 and 170. And now that the flaps are down, handle back to neutral. Not doing a very good job of maintaining my altitude here, but I'm still pretty new to the plane. Okay, beam the numbers. Let's start a gentle descent. I'm already a little high. And for the base to final, we want our speed to be around 145 knots. We're going to maintain about 145 knots. When the runway's at our 45, we'll start our base turn. Okay, let's turn base. And we're going to bring the speed brakes all the way out. The engine has extremely poor acceleration characteristics, below about 60% RPM, so we use the speed brakes to maintain a higher engine speed so that in a go-around we have power immediately when we need it. Okay, the speed brakes are all the way out. So landing checks, gears down, speed brakes out, flaps down, landing light on. Maintaining 145 on the base turn. For the final, we're going to let our speed drop to 120. Should be about 120 over the fence. Touchdown between 110 and 120. The nose has a pretty nasty tendency to rock forward on landing with the F-86. We're going to protect the nose wheel with back pressure after landing. In addition, I'm going to keep my finger well away from the nose wheel steering button. The F-86 is extremely squirrely on the ground after landing. Very easy to ground loop it. So my personal technique is not to touch nose wheel steering until I've come to a complete stop on the runway. Then I add power and taxi. But for the rollout, I'm maintaining directional stability with brakes and air rudders only, and very lightly at that. It's very easy to ground loop, very easy to come down too hard on the nose. We're on final now. I'm letting my speed drop to about 120. I'm managing speed with pitch and sync rate with power, just like a conventional airplane. Okay, bring the nose up to the landing attitude. Very gently let the plane touch the runway. Hold the nose back and let it come down easy. Throttle to idle. We'll let the plane slow below about 100 knots before applying brake. Now apply gentle and symmetrical brake to hold the center line. Very easy to scrape the plane. Be very gentle on landing. Not touching the nose wheel steering button. I'm going to let the plane come to a complete stop first. You can hear it's just getting even a little bit now. It's very easy to skid. Okay, now we can add a little power to the nose wheel steering button. We can bring the flaps up, bring the speed brakes all the way in. Flaps up, I'm going to return the handle to the center. Coming off the runway, we want to turn off the IFF. I never turned it on, so we'll just leave it here in standby. You can also turn off the pitot heat. Leaving the runway. Whoop, leaving, almost, don't overcorrect. Okay, leaving the runway, we can retract the landing lights. Now, the checklist calls for the engine to be run at 60 to 65% for about 2 minutes prior to shutdown. This is to ensure that the engine is sufficiently cool. Below 60%, there's not enough air to keep it cool, and of course above that, there's too much combustion. It needs to be sufficiently cool to shut down. So we're just going to keep the engine a little high during taxi and use the brakes to manage our speed. Otherwise, we'd have to just sit on the ramp for a couple minutes with the engine idling, the engine in a high idle. Let's save us a little time. We're going to make a right here and park it next to that hardened hangar. Okay, let's bring it to a stop here. So, for shutdown, let's turn off all of our equipment, including the lights. And with the engine having idled above 60% for 2 minutes, we now move the throttle to the off position, so all the way back, and then inboard twice. As the RPMs wind down, once they reach 10%, we'll turn off the engine master switch to close the main fuel valve. That's 10%. We'll give 5 seconds for the main fuel valve to close, and then we'll turn off the battery. Okay. And now what we need to do is bleed down the flight controls. So what we're going to do is, with the hydraulic selector in the normal system position, we're going to move the flight control, we're going to move the stick until the flight controls freeze, and that's how we'll know that there's no more pressure in the normal hydraulic system. There we go. Now we'll move it to the alternate position, and we'll do the same thing. And there's no more pressure in the alternate system. We'll pull out the alternate transfer valve. Same thing, no more pressure. Okay, this ensures that there's no leakage of hydraulic fluid. Last and final thing to do is to open the emergency landing gear lever. Unfortunately, this is non-functional in the current version of DCS, but in the real plane, we'd pop open this lever, and that would open the gear doors for inspection by ground personnel. With that done, you can open the canopy, and we are all done here. Thanks for watching. Stretch out.